Hello and welcome to helpyourmath.com. In this video, we are going to look at statistical tables and graphs, a lot of definitions. We're going to look at different types of frequencies and different data types. Let's get started. There are a few ways that we can express data. We can display information with a frequency table. That's a table showing the number of times or frequency that a data value appears. Another way we may express frequencies is using the relative frequency for each category. That's where each frequency is expressed as a percent over the total. So to express something as a percent, we would do the number in that category divided by the total, and then to convert to a percent, we would multiply by 100. And then lastly, there's the cumulative frequency of any category, is the number of data values in that category plus all preceding categories. So in our first example, we have a group of 32 students. And these 32 students, 12 received A's, 6 B's, 8 C's, 1 D, and 5 F's. We could express the data using all three of these ways. So first we have to decide which way do we want to put the grades. I like to start with just the way that it's given. So I'm going to put the A's up here, then the B's, the C's, the D's, the F's. And then I don't know why there's another column. I guess if students who are absent, no, I don't know. That's okay. We'll just ignore that bottom column. Okay, now for the frequency, remember what the frequency is? That's the column that's going to show the number of times that each data value appears. Sometimes we're given the raw data where you're given the grades. There was a 90, an 85, a 73, a 62, a 99, a 99, and we might have to tally it first, but luckily we're just given the actual number. We don't have to tally it. It's already done for us. Okay, so we're going to do that. We're going to put 12 A's, 6 B's, 8 C's, 1 D, and 5 F's. Then we have the relative frequency. So remember what the total was. The total was 32. So I guess I could include my total here. Maybe that's what I'll use this column for. I'm going to put the totals here. And here, this should add up to 32. So we can check my math and make sure the number of students matches the number of students given. 12 plus 6 is 18, plus 8 is 26, plus 1 is 27, plus 5 is 32. That works out. Okay, so here we're going to use a calculator because I can't do this in my head, and we're going to do 12 divided by 32 for the relative frequency. We want to convert to a percent, so I'm going to take 12 divided by 32 and multiply by 100%. 12 divided by 32 times 100%, and I get 37.5%. So here I'm going to say 37.5%. In the next cell, I'm going to look at the frequency of B's. There were 6 out of 32. So the relative frequency would be 6 divided by 32 times 100. I can also, because I still have in my calculator 37.5, and I know that 12 is double 6, or 6 is half of 12, so I can actually just take that and divide it by 2 and save myself a little time, and this would be 18.75%. There were 8 C's. So I'm going to say 8 out of 32. I know that 8 out of 32 happens to be a quarter, and I know a quarter is 25%. If you don't know that off the top of your head, you of course just do 8 divided by 32 times 100, and you should get 25%. This is 1 out of 32, and 1 divided by 32 times 100 would be 3.125%. 3.125%. And then lastly, we have 5 out of 32, and converting 5 out of 32 into a percent, we get 15.625%, 15.625. And then what should this total column or cell add up to? Well, they should add up to 100%. So if we add those 5 values, it better add up to 100%. Otherwise, something went terribly, terribly wrong with my math. If we had to round here, we didn't have to round, I used exact values, but if we rounded, yeah, we might come up a little short. We might get 99.9% or 100.1. That's okay. As long as it's close enough, that's fine. Now for the cumulative frequency. Cumulative frequency, this is where we start with the one we're given, and then we just keep adding on to it. So we would say there are 12 A's. So that first cumulative frequency will always match the regular frequency. Now for this, here I'm going to get rid of that. For this one, we're going to take the previous value in this column, and the previous value was 12, and then we're going to add the frequency of this row plus frequency of this row. So here we're going to do 12, the previous value, plus the frequency of this row 6, and we get 18. So we could say what that's telling us is that 18 students received an A or a B on this test. Then we're going to take the previous value, 18, and we're going to add the frequency in this row, 8. 18 plus 8 is 26. And then we're going to do the same thing. Previous value was 26 plus 1 makes 27. And then 27 plus 5 makes 32. For this total, we have the total. It's right here, right? This is what was given. That should be the total. That should match what we were given. So with the cumulative frequency, we always start with the frequency that's in that first row. And the very last input should be the total that we're given in the problem. Okay, a little more terminology. We have quantitative data. This represents counts or measurements, such as the age of a respondent. Then there's qualitative data or categorical data. These are names or labels that are not numbers representing counts or measurements, such as the state a respondent is from. So if you can put it in some sort of bucket or some category, it's probably categorical data. But if it's something that's counting or measuring, that's going to be quantitative data. Oops, one more thing about categorical data. These include numbers that do not represent counts or measurements, such as the numbers shown on the back of the Denver Broncos offensive line, right? The numbers are mostly meaningless. Like, it doesn't matter if someone's 53 versus 56. That's just a way to identify them, for the refs to identify them. The numbers that are categorical the numbers are categorical data as they make the distinction between the players. So otherwise, they don't serve a purpose. Like, when I think of quantitative data, I think of like, can we find the mean? And if we found the mean or the average, would it have any context? And if you found the mean or the average of the offensive line's numbers, that doesn't tell us anything. Okay, so we're going to play the game. Is this quantitative or categorical? The weights of a litter of kittens, what do you think? If you said quantitative, you would be correct. Yeah, that would be quantitative, right? Because this is something, going back to just like, can we do something with this data? If we found the mean, would the mean be meaningful? Yeah, it would. It would tell us something about this litter of kittens. The time in seconds of a 100-meter dash. This would also be quantitative. There would be meaning in the mean. Yes, I'm totally having fun with that. I'm so sorry. The answers of a multiple choice test. What do answers usually look like? They usually look like A, B, C, D, maybe E. That would be categorical or qualitative. It's easier to do Q's and C's as opposed to Q's and Q's though. The number of correct answers on a statistics quiz. Well, that would be quantitative. How about the models of the cars at the DMV? That would absolutely be categorical. The lengths of newborns at St. Luke's Hospital born on Halloween 2022? That would be quantitative again. These are long words. Okay. Hopefully this makes sense to you, right? I try to put some meaning behind it with the mean. I know I'm hilarious. But that's just one way to try to help you differentiate between when something's going to be quantitative versus when it's categorical. Oh my gosh, there's even more terminology used with quantitative data. We have discrete data. This is where the number of possible values is a finite number. For example, the number of home runs an MLB player hits in his or her career is discrete because it can be assigned the value of 0 or 1 or 2 or 30, but it couldn't be 30.725, right? That doesn't exist. You either get a home run or you don't. Versus continuous data. This is where there are infinitely many possible values that correspond to some continuous scale. So the speed of a train is continuous because it reaches every possible speed between 0 and its greatest speed, such as 54 miles per hour, 43.202348848 miles per hour, etc. It's impossible to count the speeds of a train at every point on the journey. And this was something I remember my friend growing up had a Cadillac with a analog miles per hour odometer, right? Odometer? I think so. And what I would notice is that when he would speed up or slow down relatively quickly, because it would be counting up, it would skip numbers. So it would go from 52 to 54, or if he's braking, 54 down to 51, down to 47. But, what I would look at it and be like, but it hit every single speed along the way. It just, the numbers couldn't keep up with how quickly he was accelerating or decelerating. Describe each quantitative datum as discrete or continuous. Datum is not a spelling mistake. That is the singular of data. Data is a plural word. Datum is its singular. The amount of sleep I got last night, this would be described as continuous. There's no way to pinpoint. It's very unlikely that I got exactly 8 hours, no minutes, no seconds, no nanoseconds of sleep. We would call this continuous. The number of students who are currently texting. So if we were in a classroom and I looked around, that would be a discrete number. I guess hypothetically, being that this is a video, maybe it is continuous, but no, because it would be, there can only be one person texting or 3 people texting, 12 people texting. There can't be 12 and a half. You can't be half texting. That's not a thing. The number of free throws a WNBA player makes, that would be discrete. We would be able to count 1, 2, 3, discrete separation between the different values that we could assign. The number of grains of sand on Earth, this was my philosophical one that I threw in here. I think you could argue this one either way. I think it's pretty close to infinite as we would ever get. You might be able to Google it and come up with some ridiculous number. So I'm not going to put anything because I think you can justify either way. Yes, you probably could sit there and count them, but it would take you forever. And the heights of sunflowers, last one, this would be continuous, right? You can try to measure it as best you can. You're never going to know the exact height. It would be impossible to get an exact height there. These have been some definitions that we use in statistics. I hope you enjoyed my examples, and I encourage you to think about other examples for each of the scenarios that I did here. Thank you for stopping by.